This is our third lesson in a series of 4 on the subject of engineering mathematics. The central theme of this particular video and this particular lesson is calculus. In your manual, you'll find the reference material in Chapter 22, and in the NCEES handbook, pages 12 and 13, and a short amount of material on page 16. 12, 13, and part of 16. The 3 major topics will be calculus, integral calculus, and centroids. If you were to take a look at the first page of Chapter 22, under the heading of subjects, you'll see a listing of these 3 major topics. And under the subject of differential calculus, there are 5 subtopics. Under integral calculus, 2 subtopics. And then the last set of material would be on centroids and moments of inertia. So this is what we'll be doing for the next 90 minutes. And this will be followed by a second videotape of 90 minutes of actually solving problems that are typical of what you would see on the FE exam. You'll probably remember from your first calculus course the definition of a derivative. And it's usually based on a diagram like this one, where we have some function, smoothly varying function, and we take 2 points that are separated by an amount delta x along this x-axis and find the corresponding values along the f of x or y-axis. And if we were to take the differential, the change in the value of the function, by taking f of x plus delta x, that's this value over here, and if we subtract from that the value of f of x, it's this value back here. And if we divide that change in y divided by the change in x, that would be the slope or the derivative of the curve in this area. Now, to make this really work, we have to make delta x be as small as possible, infinitesimally small. And so we end up putting a restriction here saying we can take the limit as delta x approaches 0. And so as this becomes smaller, and this becomes, of course, a little probably closer together, according to the drawing we have here, we approach the derivative, which we often write as df dx, or sometimes dy dx, or sometimes writes as f prime of x, or sometimes he's written as y prime of x. There are various ways of showing this operation of differentiation. This is the derivative of a function, and you'll find in the manual there are many ways of showing this notation. Before we leave the subject of derivatives, let's do a simple example by way of review. And this example is not in the manual, it's just an add-on, and I think you will benefit from the review. Let's suppose that I had the following situation. I have a function that's given by f of x is equal to 3, or x cubed minus 2x. X cubed minus 2x. I would like to find the slope of this function at x equals 3. So I have some kind of a function like we had before, some kind of a function like this. I'd like to find the slope at the point x equals 3. So I take a derivative. I find f prime of x, which is equal to 3x squared minus 2, if you remember how to differentiate polynomials. And when I take the function now, or the derivative of this function, 3x squared minus 2, I then set x equal to 3, and I get 3 times 3 squared minus 2. And so this tells me that the slope is equal to 25 at that point.